there still seems to be a little bit of confusion around agonist and antagonist. It would be really helpful if you had page 253 of Myers available to you for this. So I'd like to take you through primarily agonist right now, but I just want you to realize that almost all drugs, right, function either as agonist or antagonist. So it's the drug that is the agonist or the antagonist. What are they agonist or antagonist for? Neurotransmitters. Neurotransmitters are endogenous chemicals, meaning your body produces them naturally. Drugs are not endogenous, right? We're taking them. They're either artificially made, like synthetic drugs, or are actually extracted human-made drugs. All right, so when a drug is an agonist, it actually is a drug that basically mimics the effects of a neurotransmitter. It doesn't just usually mimic, though. It actually usually enhances, intensifies the effects of the neurotransmitter at the level of the synapse. So it's really important to remember terms like presynaptic neuron, that's the sending neuron, and the postsynaptic neuron. If you don't have these terms down, you really have to get them down this weekend. So what happens? Well, in a normal action potential, an action potential flows down the axon, and now we're at the axon terminal button, and these are vesicles right here. The vesicles are filled with these circles, which would be neurotransmitters. When the action potential reaches the axon button, the contents of the vesicles are spilled into the synapse, this area right here between the post and the presynaptic neuron. Now, normally what will happen is that there are these receptor sites on the postsynaptic neuron. So in this example, we're dealing with dopamine. And now I want you to think of the receptor site as a specific lock, like almost like a lock and key. Think about how the lock to your house or your apartment is specific for a key, meaning your key, your family's key. Somebody else's key, even in your same building, won't necessarily work on your specific door. And that's the same way the receptor sites work. There are receptor sites for dopamine, where only dopamine can land here and kind of fit here, and as a result, activate the postsynaptic neuron. Activating the postsynaptic neuron could mean another action potential, or it could be no action potential happens. But usually there will be effects of the drug, so of the neurotransmitter. So when dopamine is released into the synapse, people often feel euphoria. That's one of the effects of dopamine, not the only one. And then obviously when they land on the receptor site, that the effects continue. Okay, so that's how it normally works. Now, what happens when drugs are involved? So what I'd like to do here is not necessarily talk about cocaine specifically. I want to talk in general about how agonists can function using this picture, okay? So the first way right here is a drug can mimic, like can look just like, say, like in this case, dopamine, and can actually land on the receptor site of the postsynaptic neuron. And the effects of this drug are going to be very similar. Usually will actually be an enhancement of the effects of dopamine. So one way agonists work is they land on the receptor sites and they produce the same effects in terms of this. Either an action potential will happen or no action potential will happen. But remember, when dopamine was released and landed, we felt euphoria. Well, with certain drugs that work like this, the euphoria will be enhanced. Now, the second way, right over here, which is very, very common, is that the agonist, the drug we take, so this is how cocaine actually works, right? So cocaine actually works this way, and not just with dopamine, but with serotonin as well, and norepinephrine. So what happens is the cocaine actually will occupy and block the reuptake gates. The reuptake gates are on the presynaptic neuron, and what happens is the excess neurotransmitter in the synapse, and even some of the dopamine that lands on the receptor site after, just like how you put your keys back into your pocket after you use them. Well, some dopamine, after it unlocks the postsynaptic neuron, will fly back out and go through the reuptake gate, and so will the excess. Well, if something is blocking that, the dopamine maintains or stays in the synapse longer, and more of it can land on receptor sites. I want you to realize that the effects of neurotransmitters are not just when they land on the receptor sites, but also being in the synapse. So you can see that blocking the reuptake gate can enhance the effects of the neurotransmitter by keeping them in the synapse longer. So those are your two ways in which drugs can act as agonists. So you'll have to remember that. You'll have to know that that's how cocaine works. It's also the way antidepressants work with serotonin. They block the reuptake gate.